I welcome you all for this presentation. In this presentation, we are going to discuss about user authentication. This is the overview of this presentation. In this presentation, we are going to discuss about authentication protocols, then famous protocol, that is Needham-Schroeder protocol, then Kerberos, then X.509 authentication, and summary of this presentation. This user authentication is the very fundamental concept to security, and this is the basics for all the access control and the user accountability. So mainly this user authentication is the process of verifying and verifying the identity claimed by or from a system entity. So we have to verify the identity. So far we have seen in the last presentation, we have seen about digital signatures. You know the difference between authentication as well as the digital signature, because authentication means we are authenticated, the sender as well as the receiver are authenticated using some third party, and if there is any disputes occurring between the user and sender and the receiver with respect to the third party, that is solved, because if the sender is sending a message and someone tampered the message or utilized those message or modified something, in such cases the authentication plays a vital role. But the digital signature means if there is a dispute between the sender and the receiver, in order to solve that, we are having the digital signature, because sometimes the sender may claim that I didn't send a message, and receiver also claimed that I didn't receive a message from a particular person. In such cases, we are going in for this digital signature. But here in this authentication, mainly we are authenticating the user of this process. That is, it is a process of verifying the identity claimed by or for a system entity. We are just verifying the identity of the sender or the receiver. So here we are having two steps in order to identify or in order to verify the identity of the system entity. One is the identification step, that is, it is mentioned using some specific identifier, and another thing is the verification process. So one is the identification. These are the two main steps involved in this user identification process, authentication process. So in the identification process, we are specifying the identifier of the system entity, and in the verification process, bind entity person and the identifier are verified. So this is different from that of the message authentication. User authentication is different from message authentication. Here we are identifying or authenticating the users involved in the system entity. That is the difference between the message, or there we are authenticating the message. Here we are authenticating the user involved in the communication process. So some of the means of user authentication include that is how we are authenticating the user's identity is based on something the individual must possess. That is we know the password, that is knows. Something knows is the password of the user, or the PIN number. If you are using the bank transaction, then PIN number plays a vital role, right? So PIN in ATM card, if you want to use, means PIN plays a vital role. Then something possess, the user is possessing, that is some key or token or some cards. Nowadays electronic cards are there, so those smart cards, those are the things they are possessing. Another thing is static biometrics, such as a fingerprint or the retina. These are some of the static biometrics. Then that is the dynamic biometrics, like voice or the sign. So these four things are used in order to authenticate the identity of the user. One is the knows things, another thing is the possesses, then another is static biometrics and dynamic biometrics. And these four things are used alone, or a combination of four can also be used. If this can provide, all the four can provide the user authentication, but all the four also have some issues also. Let us see what are the issues and how it is providing the user authentication. So some of the user authentication protocols means, you know, the set of rules and procedures. These protocols are used to convince parties of each other's identity and to exchange the session keys, maybe one way or sometimes mutual. And the key issues in this authentication protocols are confidentiality. Confidentiality is to protect the session keys. Another thing is the timeliness. It is to prevent the replay attacks. Next, we see what is a replay attack. That is where a valid signed message is copied and later it is resent. That is, there are the different categories of replay attack. Simple replay attack, repetition that can be logged in, then repetition that cannot be detected, and backward replay without modification. These are some of the categories of replay attack. And the countermeasures include in this replay attacks includes use of sequence numbers. This is generally impractical. Another thing is timestamps. Using the timestamps, that is the distributed system needs to be synchronized, must have the synchronized clocks. Another thing is challenge response, using a unique nonce. You know what is a nonce? So using the unique nonce also, the countermeasures can be applied in this replay attacks. Next thing is one-way authentication. One-way authentication means it is required when sender and receiver are not in communications at the same time. Say for example, email. Because if we need to have a phone conversation, at that time both of them must be in the line. Then only both of them must have the communication. But if you send a mail, it is not needed to have the another person in online at the same time. When I am sending a mail, it is not necessary that the receiver has to receive immediately. The receiver is receiving, but he can view once he is coming in online. So this we only calling it as a one-way authentication or one-way communication process. Here we have a header in clear, so can be delivered by the email system. May want contents of body protected and sender needs to be authenticated. Using symmetric encryption process also we can perform this authentication. That is, we can use a two-level hierarchy of keys. Here we are using a trusted key distribution sender. In the first class itself I have told that if you want to share the keys mutually we can share, otherwise we have to have a trusted key distribution sender. Third party key distribution sender we may have. So each party shares one master key with the KDC, key distribution sender, and KDC generates the session keys used for connection between the parties, and master keys are used to distribute these to them. So if I and you are communicating means I have to send the master key to the key distribution sender. That key distribution sender is the trusted third party. Trusted key distribution sender I have to send, and the key distribution sender generates a session key and share to both the communicators. The famous authentication protocol is Needham-Schroeder protocol. It is a original third-party key distribution protocol for session between A and B mediated by the KDC. I already told you, if Alice and Bob are communicating means they need a trusted third party. Here the trusted third party is the key distribution sender. So how they are communicating with the help of the KDC? Let us see. These are the 5 steps involved in this Needham-Schroeder protocol. It is a third-party key distribution protocol. First, A sends to KDC, that is identity of A, then identity of B, and the nonce 1. Then KDC sends to A, that is encryption of KA, KS combined with IDB, because A is communicating with the B. So IDB concatenated with the nonce N1. Then encryption of KB, KS, that is the shared secret key concatenated with ID of A. Then A to B. So A is sending to KDC, then KDC to A, then A is sending to B, then B to A, and A to B. Likewise it happens. A to B is E of K, B, KS, IDA. What is this value? See here, whatever the KDC sends, that value only, here it is, you see, this value and this value are same. Whatever the KDC sends to A, the same value only sent to B by A. Then B to A, E of KS, nonce 2. Then A to B is E of KS, F of some function of the nonce 2. These are the 5 steps involved in this Needham-Schroeder protocol. Here it is for the key distribution, and A and B are communicating with the help of the mediator key distribution center. So this Needham-Schroeder protocol is used to securely distribute a new session key for communications between A and B. It is vulnerable to replay attack if an old session key has been compromised. We have already seen what is a replay attack and what are the categories of replay attack and how to countermeasure the replay attack. Then message 3 can be resent convincing B that is communicating with A. Modification to this address is requires timestamps in steps 2 and 3, and using an extra nonce we can secure further. If you are it was attacked using some replay attack, then we have to use these measures. Then one-way authentication in this Needham-Schroeder protocol is use refinement of KDC to secure mail since B is no online. That is one-way authentication means just like a email communication, the A is sending to B, but B immediately not viewing everything. It is receiving, but once he becomes online, then only he can view it. So one-way authentication. So since B is not in online, so drop steps 4 and 5. Then only 3 steps are there. Simply we are sending. B is not communicating further to A. So A to KDC, IDA, IDB and on so on. KDC to A, the same procedure only. Then A to B, just sending to B. Provides encryption and some authentication, but does not protect from any replay attack. Now, another thing is Kerberos. It is a very famous trusted key server system from MIT, Kerberos. By just hearing the name, you have to remember that it is a trusted key server system. It is also for authentication. It provides centralized private key third-party authentication in a distributed network, allows users access to service distributed through the network without needing to trust all workstations. Rather, all trust a central authentication server. Here it is a trusted centralized private key third party authentication server, trusted key server. So we are not communicating with all the workstations. Instead, we are trusting on authentication server, and whatever we need to send, we are sending to the server. The server only communicate that to the concerned parties. There are 2 versions in use of this Kerberos, that is version 4 and 5. Next is the Kerberos requirements. It was first reported that the following are the requirements identified for the Kerberos. One is secure. We need a secure form of the server, then reliable, then transparent and scalable. And this Kerberos is implemented using the authentication protocol based on Needham-Schroeder only. Already we have discussed about Needham-Schroeder protocol. It's an authentication protocol. Now we are going to discuss about Kerberos version 5 because the most widely used Kerberos is version 4 as well as version 5. Let us discuss version 4. It is a basic third-party authentication scheme, and here we are having the authentication server. Why we are going in for this Kerberos means instead of communicating, the sender is communicating to the receiver directly, we are going in for the authentication server. Using the third-party authentication server, whoever wants to send a message to the concerned party, they have to first send the message to the authentication server, and authentication server will take care of whatever the ways of communicating to the concerned party. So this Kerberos v4 is having an authentication server that is named as AS. Afterwards and all, we are just describing with respect to the abbreviation only. Here in the authentication server, usually the users initially negotiate with the authentication server to identify self. Then authentication server provides a non-corruptible authentication credential, that is a ticket granting ticket. That is TGT is a ticket granting ticket. So the authentication server, first whoever wants to communicate, they have to negotiate with the authentication server that I am only going to communicate to some person. Likewise, they have to just register them. It's just like a registration process. While registering, the authentication server is providing a ticket granting ticket. It's a ticket. That is, it is a non-corruptible authentication credential. That is just a token or ticket. And those who have a ticket, and we are having a ticket granting server also. Here user subsequently requests access to other services from this ticket granting server on basis of the user's ticket granting ticket. So they can communicate or using the whatever the ticket they have received from the authentication server, they can use this ticket granting server using a complex protocol using DES. So these are the steps involved in Kerberos 4, that is authentication service exchange to obtain ticket granting ticket. First, how the user is communicating with the authentication server, and authentication server is just giving a ticket to the user. See, that is the ticket granting ticket is issued to the user. Next is ticket granting service exchange to obtain service granting ticket. So first they have to authenticate themselves in the authentication server. After receiving the ticket from the authentication server, they have to go in for the ticket granting server. In order to exchange the service granting ticket, they have to go in for this ticket granting server. So C is just sending message to ticket granting server. Then the ticket granting server is giving the service, whatever the service it is asking, it is giving to the user. Next, client server authentication exchange to obtain the service. Basically, we need a client server communication only. Here, see here C to V. So, client server authentication exchange in order to obtain the service, C is communicating with the V, that is ticket concatenated with the authenticator, then V to C. For some mutual authentication, V is sending the message to the user. So these are the steps involved in Kerberos V4. That is, first is authentication service exchange to obtain the ticket granting ticket. Next, we are having the ticket granting service exchange to obtain the service granting ticket, and finally we are having the client server authentication exchange to obtain the service. So this is the overall block schematic of the Kerberos version 4. We have already seen that in the Kerberos it is an authentication server. It is a server. So here we are having the authentication server as well as the ticket granting server. Two servers are available. See here, first is the user logs on to the workstation and requests service on the host. Then what is the second step? Then authentication server verifies user's access right in the database, then creates a ticket granting ticket and session key, because they have to create a session in order to communicate. Results are encrypted using key derived from the user's password. Then third step is workstation prompts user for password and user's password to decrypt incoming message. Then sends ticket and authenticator that contains user's name, network address and time to the ticket granting server. Next, the fourth step is ticket granting server decrypts the ticket and authenticator then verifies the request, then creates a ticket for the requested server. And the next step is workstation sends ticket and authenticator to the server. Finally, the server verifies the ticket and authenticator match, then grant access to service. If mutual authentication is required, server returns an authenticator. So these are the steps involved in this Kerberos V4. So it is authentication server. So in order the user wants to communicate with another receiver, then they have to get the permission from the authentication server. From the authentication server, they are just getting the ticket. Then using the ticket granting server, they have to use the ticket and get the service. Then only they can send something to, or we can provide the authentication. That is, the server verifies both the ticket as well as the authenticator match. So whoever the user is sending the ticket to the server, and finally it is, see here, it is requesting the service, provide server the authenticator. So all these things in between, how the communication is happening between the user as well as the Kerberos as well as the server. Actually, we need a client server communication only. In order to have the client server communication with the help of the trusted third party key distribution center, we are going in for this client server communication. Generally, directly we communicate from the client, communicate to the server, but here using the trusted third party, because we need to have some authentication. Only appropriate or authenticated user only communicating to the server. In order to authenticate the identity of the user, they are going in for this Kerberos. It is an authentication server. So here we are having two servers, authentication server as well as the ticket granting server. These are some of the Kerberos realms. That is, a Kerberos environment consists of a Kerberos server, a number of clients all registered with the server, then application server sharing keys with the server. This is termed as realm. So Kerberos realms means this is termed as. So this environment consists of a server. See here, realm A and realm B is here. So in the client side, it is communicating with the Kerberos. So in the Kerberos, we are having the authentication server as well as the ticket granting server. Then here in realm B also, this Kerberos is communicating with the user. So in such a case, and the server is also there. So this term, the Kerberos server, the number of clients involved, then all registered with the server. Clients that are registered with the server, then application server sharing keys with the server. These are called as a realm. Typically, it is a single administrative domain. If multiple realms, then Kerberos servers must share keys and they are providing the trust among the realms also. Next is X.509 authentication service. It is also part of CCITT X.500 directory service standards. So it is a distributed service maintaining user information database. It defines a framework for authentication service. Here the directory may store some public key certificates. So certificate authority concept is involved in this X.509 authentication service. With the public key of user signed by the authority also defines this authentication protocols. It uses the public key crypto and digital signature, public key cryptography and digital signatures. That is, algorithms are not standardized, but generally this Rivo Shamir Edelman is recommended here. So X.509 certificates are widely used and there's 3 versions. So this is the structure of the X.509 certificates. Here you see that is unsigned certificates contain user ID with user's public key. Then the hash function is generated, that is hash code is generated with the unsigned certificate. First we are having the unsigned certificate, then hash code is generated. Then with the help of the key as well as the signed hash code with the certificate authority's private key, we are forming a signature. Then signature is attached with the certificate. So we are getting the signed certificate. So the recipient can verify the signature using the certificate's authority public key. So we are having a certificate authority. In X.509 certificates, we are having a certificate authority. So whatever the authentication process happens, there we are having a signature also, but we need to verify whether this signature is valid or not, or correct or not. Likewise, we have to verify. So that we are just verifying whatever the signed certificate received, we are verifying the signature with certificate authority's public key. So we can verify the certificate using the public key of the certificate authority. So here we are having issued by a certificate authority containing version 1, 2 or 3. Then serial number is there. In the certificate, what are the contents in the certificate? Serial number, then signature algorithm identified, then issuer of the certificate, period of validity, then subject public key information, issuer unique identifier, subject unique identifier, extension field, signature. Then a notation like as the CA denotes certificate for A signed by the certification authority. That is the meaning here. So here you see the version, that is X.509 certificate looks like this, and the certificate revocation list. So whatever we have seen earlier in the previous slide, the same thing is given here. Version, certificate, serial number, algorithm, parameters. That is, in the version 1 it contains these things, and in the version 2 it contains up to the subject unique identifier, and in version 3 it contains up to extensions. Finally this signature is involved in all the versions 1, 2 and 3. And this the certificate revocation list consists of the algorithm or parameters, then issuer name, then update date, next update date, then user certificate. Here only we are having the revoked certificate. Then here user certificate, serial number, then revocation date. How many times the certificate is revoked, all those details are here. Then finally signature is there. So how many times the certificate is revoked, all the details are provided in the certificate also. So how to obtain a certificate? We are speaking about a certificate, but how to obtain a certificate? Any user with access to the certificate authority can get any certificate from it. Only the certificate authority can modify the certificate. Here, if you are getting a certificate, actually in the certificate we are having some certificate, but we can't sign in the mark transcripts or in the degree certificate, all those things we are having some signature of some authority. But in that we can't sign in those certificate, because the authority is having only the authorization for signing in the certificate. Likewise only in the digital signature, digital certificates also, whoever is the certificate authority, they only can sign in the certificate, and from them only we can get the or obtain the certificate. Only the certificate authority can modify a certificate. Here others are not having the option to modify the certificate, because it cannot be forced. Certificates can be placed in a public directory, because always the certificates are placed in the public directory and it can't be forced by anyone. So the certificate authority is having the authorization to modify the certificate. And we are having the certificate authority hierarchy, that is if both users share a common certificate authority, then they are assumed to know its public key. Otherwise, certificate authorities must form a hierarchy. Use certificates linking members of hierarchy to validate other certificate authorities. Each certificate authority has certificates for clients, that is forward, and parent, that is backward. Each client trusts parent certificate. Enable verification of any certificate from one certificate authority by users of all other certificate authorities. So in this presentation, we have discussed about user authentication, that is introduction to user authentication, and we have discussed about the authentication protocols. Then a very famous protocol is Needham-Schroeder protocol, and we have seen about the authentication server, that is the Kerberos server. There how we are obtaining the ticket, that is ticket granting ticket from authentication server and the service from the ticket granting server. Then we have seen about X.509 authentication, how to provide the certificate, how to get the certificate, and how to verify the certificate, that we have seen in this X.509 authentication. Thank you.